Let's look at DACs, or the DAC on your STM32F4. And you have two 12-bit buffer DAC channels or converters with the option of selecting either 8 bits or 12 bits. You can generate the noise wave generation or a triangle wave generation. They have the module built in there to generate these two types of waves, and you can do dual DAC channel independent or simultaneous conversions. What's inside of the DAC? This is what you have. So this is the part here where you control the random generator, or the noise wave comes from a random generator here, and on the right you have your triangle wave, and this is the register where you put the values for your DAC with 12 bits, that then it goes to your DAC and comes out. And you can also have those trigger sources triggering your DAC, so you can feed signals or variables or values to the register, to the output register. So let's go over the noise and triangle wave example. So pretty much in terms of code, what I'm doing is just configuring the timer 2 with no interrupt routines, just with the trigger source, and then configuring the DAC, and you don't need to do anything else, then everything runs by itself. And this is the noise, and in green you have the variables that are being changed in the code. The DAC is going to be exactly what it says on the peripheral drivers of your Atelic IDE. And here, this is where we tie together with the timer 2 trigger source, and also what type of wave do you want. In this case I have the DAC wave generation triangle. If you switch triangle to noise, you will produce a noise wave. And I'm using channel number 1 here. And then your timer, again, you're familiar with the timer. I'm running the timer here at full speed just to see what's happening. How fast can I run this DAC? And this is how I tie together with the trigger source, similar to what we did with the temperature sensor. No interrupt routines, and that's it. Now for the wave generation, so I'm also providing an example for a wave generation. The difference is that we're not going to use these trigger sources. We're going to use an outside timer that is going to provide the value that we want to this output register of the DAC. This one, it's just disabling the triangle and the noise generation, just saying that I'm going to use my own thing. And this is the code that you have. You have the main, you parameterize the timer, the DAC, and now here it's when you do the DAC output, and this part is connected to the timer interrupt routine through a variable, timer 2 flag, which is volatile. And this is how these two, the main and the interrupt routine, communicate together. So let's look at the DAC. The only difference now is exactly the same as the previous code. The only difference is that I put wave generation none, so I don't generate any triangle or noise wave. In terms of timers, I just add, so I'm going to comment the trigger source and add the interrupt routine stuff. And on my main code, so I declare some types, enum types here, where I have like a library, a .h file with the sine, triangle, sawtooth, and square wave values. And all I need to do is, if you go here, you choose the type of wave that you want to generate. So just put sine, triangle, sawtooth, or square, and the code will take care of generating that. I'm actually having I'm using two channels here, the two DACs, channel 1 and channel 2, and whenever I put sine, it just does a different wave for channel number 2. But the square wave, because it has less samples, I just have channel 1 and channel 2 generating the square wave at the same time. So if you have the ability to see these waves with an oscilloscope, that's great. If not, I'll provide a video showing all these so you can see things working.